Alright, so remember when you draw these triangles, they don't have to be perfect. Just give yourself something that you can label so you can kind of see how everything's related to each other. And it doesn't really matter that much where you label your angles as well, but you should label them. That way you know what you're actually talking about for angle such and so, and then you also know where side such and so has to be, because it's got to be across from your angle. So based on what we know here, we know side A is supposed to be 11, so that's going to be across over here. We know side C is supposed to be 14, so that's got to be across over here. And we're given that angle B has to be 34 degrees, so that's going to be this angle right there. So based on what you're seeing here, why do you suppose we need a law of cosines?
There's only adjacent and hypotenuse, because there's no opposite.
Okay, well there's no hypotenuse either, technically, right? Because it's not a right triangle. But with what we were talking about the last couple of classes, if I were to just have law of sines at my disposal, would I be able to set up a proportion? No, because I don't have anything opposite. So I have this one angle that they've given me, but I don't have the side opposite from it. So there's no way to set that up in a ratio. And I've got two other angles that I don't know. So there's no real way of knowing what those two other angles are supposed to be at the moment either, just based on the fact that angle B is 34. So there's no way to get angles to be across from any of the sides I know. So this is a situation where we have side angle side, SAS, right, where the angle is included between the two sides. And in this situation, law of sines doesn't fit. So that's why we need this other law, which is the law of cosines. And the law of cosines says this. So if we have our triangle ABC that has sides of length A, B, and C as shown, so the same kind of triangle as what we were looking at with law of sines, the fact that angle A has to be across from side A and so on, then it is true that any one of these statements has to be true. Now what you need to realize here is these are not three separate statements. These are three versions of the same statement. So the statement is the law of cosines. And there are three different versions of it depending on which of the angles you were given, because that's what you're going to be taking the cosine of. Okay? So if I'm given angle A, then I would want to use this first version for the law of cosines. If I was given angle B, then I would want to use this second version. If I'm given angle C, then I want to use this third version. Okay? And the thing to really notice here about the version that you want to use is whatever the angle is in your cosine, it is the side opposite that should be out here being squared by itself at the beginning. So you can see here I've got angle A, and out here it's side A being squared. Here I've got angle B, so out here it's side B being squared. Here I've got angle C, so out here it's side C being squared. Okay? And then the rest of what's in between here is just going to be made up from the other two sides. So if I'm talking about angle A, side A is what's out here being squared, and so the other two sides, B and C, are what make up the rest of what's in this statement. I take the B squared plus the C squared, and then I subtracted 2 times B times C, which gets taken times the cosine of A. Here, when it was the B that I took cosine of, that meant it's the B getting squared out here, so then it's A and C that make up the rest of this. It's the other two sides. Okay? So if we come back now to what we were talking about, we know this, we know this, and we know this. Okay? So what would my law of cosine statement look like with the given information?
B squared equals A squared.
So for this situation, what would it look like? B squared equals what?
11 squared
11 squared
plus 14 squared
plus 14 squared.
minus 2 times 11. And then cosine of 34.
That's the version we want to use. All right, so if we go to our calculator, let me erase some of this stuff. And new actions. Oh, yes, it is. Delete. Clear history. That's what I want. There we go. All right, so we're looking at taking 11 squared plus 14 squared minus 2 times 11 times 14 times the cosine of 34. And since you can see up here, I already have this in degree mode, so I don't need the degree symbol. It'll act like a degree all by itself. Control Enter to get a decimal answer. And I've got about 61.6564. So what did we just find? 61.6564 is what? What is it? B squared. Okay, so we've just evaluated all of this stuff, but that now is still equal to B squared. So in order to actually get B, we need to take the square root of it. Now, I highly recommend to you that you try to continue using the number that the calculator gave you. Even though you're only seeing 4 decimal places in this answer, the calculator probably has many more decimal places in its memory. So to take the square root of this and still be as accurate as I can possibly be, I'm going to go with my square root sign here, and then I'm going to go control negative sign for previous answer. And that way it will give me the 61.6564 blah, 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 blah. Like however many more decimal places the calculator has kept, it's going to use that in this answer. So it just helps make it a little bit more accurate. Okay? And so again, I'm going to do Control Enter to make sure I get a decimal answer. And we're looking at about 7.85, 7.9. Okay? That is what B is. And that's what's going to go here. Okay? Now, what if I want to find angle A next? What can I do now to find angle A?
Law of Cosines.
Yeah. So usually what happens is if you're given a situation where law of sines won't work, and therefore you have to use law of cosines, once you get the answer from the law of cosines, that usually allows you to go back now and set up a law of sines problem for the next piece. So we now have an angle and a side across from each other. So I can now set up a ratio that I know. And then I can set up another ratio for the piece that I want. And now I'm right back to what I was doing in 3-1 and 3-2. So 3-1A and B, sorry. Okay, so go ahead and figure that one out. What are we going to get for A? So what do we get for A?
51.9
51.9.
degrees. Yeah. Or 51.58.
So you took 5, 8 and made it 9.
Yeah. Wait, no.
Or K.
51.6.
51.6 sounds a little better from that result. Is that what everybody got? You agree with that?
Yep.
Okay. So if we make this a 51.6, then what do I need to do to find angle C?
180 minus 51.6 minus 44.
Yeah. So now that we've got two of the angles, all I have to do to get the third angle is just subtract from 180. And what's that going to give us? I'm doing it in my head faster than you guys are punching it on your buttons. Come on, what's that going to give us?
Oh, 94.4.
Thank you. And my head's not doing so well these days, so if I'm doing it in my head better than you're doing it on the calculator, there's something wrong. Okay? So usually the law of cosines is just something that we need to use once to kind of get the ball rolling. Because the information that they initially give us is not something we can use in a law of sines. So we have to use law of cosines to get one of the pieces. But usually that one piece then allows us to do the rest of the problem with law of sines and subtracting angles from 180 and the simple stuff that we did in 3.1. Okay? So law of cosines is a little bit more complicated than law of sines is. But it certainly is very useful when we get this kind of SAS situation, because law of sines doesn't work in that case. Okay. Another example where law of sines is not going to work is if we're given three sides. So no angles at all. We're just told what the three sides of our triangle is supposed to be. So we still need to set up angles A, B, and C, even though we weren't given an angle, because it's based on those that we end up knowing which side is which. So side A is going to be 12, side B is going to be 27, side C is going to be 20. Okay? So again, law of sines isn't going to work because we don't have any angles to match up with any of the sides. So we're going to have to use the law of cosines again. And we don't have any of the angles, so is it going to matter which one we start with? Yeah, it does. Okay? Here's why. If you think about what we're going to do here, we are going to fill in the law of cosines statement with all of the sides. And then we're going to try to solve it for angle B, or C, or A, or whichever one we pick. Which means at some point, we're going to end up having to take inverse cosine to find out what the angle is. Okay, does that make sense, everybody? Okay. Well, because I'm doing inverse cosine, remember, what is the interval of values I'm allowed to get an answer from for inverse cosine? From where to where? Come on, we just did it. Inverse cosine, I get answers from where to where? Well, there's only two options. What was one? Say again. No, inverse cosine, inverse trig. End of last chapter. When I take inverse cosine, inverse sine, inverse tangent, remember there's a certain range, a certain interval of numbers we were allowed to get an answer on. And sine and tangent had the same one, and then cosine had the other one. What was the range for cosine? Might have been why many of you missed the problems in that section. So like I said, there's only two options. Either we went from negative pi over 2 to positive pi over 2, or we went from 0 to pi. Those are the only two options we had. So which one's for inverse cosine? Sorry. That one's blank. That one's cosine. That's cosine. What do we have to limit that to be able to pass the horizontal line test? Pi to 2 pi. Let's see, pi to 2 pi, there we go. Pi to 2 pi would have been this piece. Would that have worked? Yes, but was that the piece we used? No, so what was the piece we used? 0 to pi. Right? By limiting it to that piece, then when we did the inverse, we would have ourselves a function. It also means that those values now become the range. Those are the answers that we get. So when we do inverse cosine, we can only get answers from 0 to pi. First quadrant, second quadrant. If I get an answer that's in the first quadrant, then that means it's an acute angle. But if I get an answer in the second quadrant, then what kind of an angle am I talking about? Obtuse, right? If I end up with an angle that rotates over and stops in the second quadrant, then I'm talking about some kind of obtuse angle. Okay, so what does that have to do with this? Well, if there is the chance that one of my angles could be obtuse, I have to start with that angle. Because if I do find it to be obtuse, then I know automatically the other two angles have to be acute. So then when I go do inverse sine stuff, no problem. Okay? Even if I end up trying to find the obtuse and it ends up acute, I can still be assured that the other two are going to be less than that and therefore still be acute. So when I go find inverse sine stuff, it's still no problem. So the reason we make sure that all works out for us, the way that we make sure that all works out for us, is that we have to take the biggest angle as the first angle we find. Now, how do I know whether A, B, or C is going to be the biggest angle of the three?
The biggest angle. So B would be the biggest angle. The biggest angle of those three.
So B is going to be the biggest angle because of why?
Because it's the largest out of those three.
Yeah, so out of the three sides we have, side B is the longest side. And we made a comment the other day in class that the largest angle has to be across from the longest side. The smallest angle has to be across from the shortest side. So if there is going to be an obtuse angle, it's got to be the biggest angle in the triangle, because there's no way to get something bigger than obtuse. You can't have two obtuses in a triangle. Okay? So you always, always, always want to start with whichever angle is going to be across from your longest side. Determine if you actually have an obtuse or not. And then your other two angles are going to have to be acute no matter what you end up with for B, and inverse sines will take care of that. Okay, but if we end up trying to do an inverse sine on something that's supposed to be obtuse, what we're going to end up getting is a negative angle, and that doesn't make any sense whatsoever in a triangle. Okay? Alright, so what's this going to look like if angle B is the one I want to try to find? What's my law of cosines statement going to look like?
B squared equals
So use these numbers.
27 squared. Equals whole squared. Plus 20 squared. Minus 2 times 12 times 20. Cosine B.
Good. That's exactly what it should look like. So if we're trying to find angle B, we're going to have to start with side B. Okay, so what should I do first to find angle B? Okay, so we can work like all of this stuff out, right? Kind of simplify a little bit. So the square of 27 is what? 729. Okay. 12 squared? 20 squared? 2 times 12 times 20.
40.
And then we've got our, cosine B. Okay, so that gets the numbers a little bit more usable for us. Then what?
Plus 244
And what's that going to be?
544.
544. Next step? Subtract what? Can I subtract the 544 and the 480? No. And that is actually the most common mistake that people make on this problem. Why not? Why can I not subtract 544 minus 480?
What is the 480 multiplied to cosine B?
Exactly. The 480 is being multiplied over here. Order of operation says I got to multiply before I can subtract. So trying to subtract the 480 is going to get me in loads of trouble. It's going to totally mess up my answer. So what do I need to do next instead of that?
Minus 544.
Yeah, so minus this 544 that I have. And leave the negative 480 out there as a coefficient on cosine of B. So 729 minus 544, 185. Okay, so now what do I do to get cosine B by itself?
Divided by 480.
We actually divide the 480 because we're multiplying it by cosine B. Okay, so cosine B ends up being what? 0. What? 0.3854. 3 or 4 to write down is fine, but again, keep it in your calculator. Okay, we're going to try to do the next step with it in our calculator. But as far as writing down the steps, 3 or 4 digits is fine for what you write down. So now what am I going to have to do to actually get B? Inverse cosine. So I'm going to take, so if you did this part already, your 185 divided by negative 480, and you got that answer. Okay, now you can do inverse cosine, and then again do your control negative for previous answer. And that way it'll keep lots of those decimal places in there. I mean, look at how many decimal places are actually there. So it'll keep all of those decimal places in there and give you a much more accurate answer. So it looks like angle B is going to be 112.7. And that's an angle, so that's degrees. Okay, so just be really careful as you work this out. Make sure you are following proper order of operations. Do not try to combine this one with this before it's time. Okay, subtract that 544, then divide by that coefficient on cosine and work from there. All right, so I did have an obtuse angle in this case. 112 is obtuse, which means A and C have to be acute because there's no way to get more than one obtuse in any given triangle. So because A and C are going to be acute, doing inverse sines is going to work out just fine, and it doesn't matter which one of those I do first. So I've got to do the biggest angle first, but then after that, it's up to you. So let's try A next. What should I do to find angle A? Ideas?
Would you do the same as like what we did with B? So like
You could set up all of this again and try it with A. Is there another option that maybe is a little bit simpler?
The law of sine.
Yeah, go back to law of sines again. Because now I've got an angle and a side that are across from each other. I can set up a law of sines because I've got one complete pair. Right? So now I can go and say, all right, so if I take the sine of this 112.7 I just found, put that over the 27 now, then that's going to have to be equal to the sine of this A angle I'm trying to find over the 12. Okay? And again, because I know A's got to be acute, doing inverse sine on that's going to give me the acute angle I need, so it's all cool. All right, so work that one out. What are we going to get for A?
Can you show me again how to get your previous answer in there?
See where it says A and S right there above the negative? So because it's blue, that means you're going to go control first. So
Okay.
control minus.
Okay, thanks.
Anybody got it? What's angle A? How much?
Is it
24.20? Yes?
Yeah.
Yes? I better retry mine then, because that's not what I got. 112.7 sine of that times 12 divided by 27 equals, take the inverse sine, degrees, that's okay. Okay, try one more time. 112.7 sine times is 12, right? Yeah. Equals divided by 27 equals inverse sine. Aha, there it is. I don't know what my calculator was doing. Okay, 24.2. Now I believe you. All right, and then for angle C. What do we do to find angle C? Okay, so what do we get?
43.
How much?
43.
43?
Yeah.
Point what?
Yeah.
1? All right, does that make sense? So when you are dealing with these kinds of solve the triangle problems now, you need to look at what you're originally given. Decide, is this going to fit better for a law of sines or law of cosines to start out? If it's law of sines, pay attention to whether it's SSA or not. So do I need the foldable or not? Okay. If law of sines is not going to fit, then set up law of cosines to get your first piece. And if the first thing you need to do is to find an angle, make sure you're finding the biggest angle first. Okay? Once you get that first piece with law of cosines, then you should be able to go right back to law of sines and figure out the rest. Okay? All right, so we've got a little bit of time here. It's Wednesday, so I gotta make sure I'm looking at the right time. Wednesday, C, 1:50. Okay, we should have quite a bit of time. So we're going to use this now for a smaller scavenger hunt than usual. There's only 5 problems, but they are word problems. And they are a mix of problems between having to use law of sines or having to use the law of cosines to get your answer. Okay? So there are 2 problems in the back. There's 1 problem over here on the bulletin board, and then there's 2 problems up here in the front. And again, just a quick reminder, you're going to look at the problem on the bottom half first, work it out, come up with your answer, and then find the problem that has that answer at the top half, that's where you go next, and you work out the next problem that's on the bottom half of that sheet. Your answer sheets are a little bit different this time. One, because I gave you so much space, so you should have plenty of room there that you can draw a little triangle if you need to, or draw a picture of what's going on, label what you know, and then use that to come up with the piece that you are being asked about. But I also, because these were so big and I had so much space, over here where we usually identify the problem, like I went from A to G to K to B, instead I made a list based on the heading of the problem. So each problem has this bold heading at the beginning of it, and so I've just listed all 5 of them here. So if you were to start at this one, because this one's walking, you just check the walking box as being a way of saying that's where I started, that's the problem I'm working on. And then when I go over here next, or wherever you go next, and it's like, okay, camping is next, so I check camping. Okay? That's the way you're going to identify your problems, is just with a check mark as to which one you're at. And again, if you've done this correctly, when you do the last problem, your answer should take you back to the first problem that you did. So that's kind of the way that you know that you've done it correctly. Come up and check with me to make sure you've done it correctly. And then we're going to do this just a little bit differently as well, in that I'm going to allow you, if you want, to work with one other person. If you prefer to do these by yourself, that's okay. If you want to work with someone else, one other person. Okay? When you're finished, you'll come check with me. The first person or group to check with me is going to get to choose first which of the 5 problems they're going to show us how to do. So either at the end of class today, or if we run out of time, the very beginning of class on Monday, we're going to have you show us how to do each of these problems. So the first person or group gets to make the first choice as to which one they want to show. And then the second person or group will get the second choice, and so on. If there's any we don't choose, I will go through them if we need to. When we do it, again, either to end of class today or on Monday. But you'll get the choices in order of getting finished first. If we have time today, we'll do it quick then. Based on what happens C block, we'll probably put it off and do it very first thing on Monday. When you do get finished, if others are still working and you're waiting, there is the 3.2 practice in your booklet, so you can start working on that. That'll be due for Monday. I believe, if I remember correctly, there was a quiz on Monday over this first part, so there should be a practice quiz in your booklet. You can be working on that. I will get all of the answers posted on Canvas sometime today or this evening. So the answer to, I'll put 3.1b up. So if you want to take another look at it, I'll put 3.2 up. I'll put the practice quiz answers up. I'll get all that stuff up for you so you can be checking over the weekend. So Monday will come in. We will go over any questions that you have from 3.2. We'll do the quick sharing of these problems, showing how you set it up and how you got your answer, and then we'll take a quiz. Okay, so that kind of gives you an idea of what to expect for Monday. And I'll try to get all that updated on Canvas today as well. I know that's gotten a little bit behind, so I'll try to get that updated today. Any questions about what's happening, what we're doing? All right, so let me get, oh, of course my paper is out. Let me fill this with paper so I can get my other copies here. Let's get started. You will need your calculators, so feel free to use those. I don't expect you to figure these out without them. Alright, so remember you can start at any one of them to get started. Keep in mind that this paper over here, we had a little trouble coming up with the right answer. It really is meant to be the 274.61. Okay? So if you get anything like that, you're going over here. But start wherever you want. Make sure you get around to all 5. And check with me when you think you're done.